Video we're going to be focusing on alkynes, but there's a couple of things we need to finish up from last time. We talked about these two, and really there's two different names. You can name it. Technically, I was looking in my notes, and here's what my notes say on this. But then at the same time, I looked it up, and both are valid. You know, you can buy them at a chemical store with both names. Technically, though, if you're following IUPAC, there's a substituent on one of the double bond carbons that gets number 1. Substituent would be like an alkyl group. So there's no substituent, here there's a substituent. So that's why that one gets number 1. And then they count this way. And it wouldn't be 1, 2. And you always have to follow the double bond. So technically, it would be 1,5-dimethyl cyclopentane. However, I'll show you. I was looking up on a website of chemical purchasing. Where is it? Here it is. They just said 2,3-dimethylcyclopentene is not an oh, come on. It's like, okay. But here we got 2,3-dimethylcyclopentene for sale. So
how much is it?
I don't know. I would have to.
What is it? Like,
I'd have to add it to the cart.
Add it to the cart, and then
You probably have to have some credentials, so they don't ask me.
they're gonna sell me.
Yeah. So, can chemists be a little sloppy with their naming? Apparently. So. But IUPAC would have to say that if it's a substituent connected, then that's where you start your counting. Is that going to be on an IB test? No. So, but just fun fact. All right, and then we got another one. Here's another weird one. We got, what is this, a hexane? And I know we got a 1, 2, 3. That's a propane. Would that be right? Propane. All right. So here's where basically you've got it either 1, 2, 3 or 1, 2, 3. Let's do it. 1, 2, 3. And how you start the counting is you start from this group right here, even though this would be a lower number. So instead of it being 1 propene, it would be 2 propene. And then, since this is like the side chain, it would be propenyl and then cyclohexane. So I'm just showing this example because does it get harder? Are there other situations? Yep. You're not going to be asked that on the IB test. And here's the same deal. We got 1 carbon hanging off, but it's a double bond. Normally this would be a methyl group. But if it's a double bond, instead of methyl, we'd call it methylene. To show the double bond and to show that it's an alkyl group. And then what's this main chain called? Cyclohexane. Alright, so it's going to be, what's that? If the double bond was within the cyclohexane, then it would be cyclohexane. Yeah. But since there's no double bond in here, then it's cyclohexane. Yeah. Again, that's another tricky one. It's going to be more straightforward like these. That's where it's going to be the bread and butter.
Is that more of what we're going to see?
Yep, on the quiz and on the IB test. I think I added these there because one year people asked, oh, what if you had this? Oh, what if you had that? Okay, well, here you go. What's that? Quiz is tomorrow, yep. It's summative. It's like 30 points.
So it's a test.
I guess it's a small test. Yeah. It's mostly the alkene stuff we talked about, and then there's like 2 or 3 of these alkyne stuff. Are there challenge problems?
No, those last.
No, there's no challenge problems.
Okay,
No.
so they're just problems.
Yeah, it is problems.
Problem now.
All right, so we already alluded to this. If it has an ine ending, it's a triple bond. Ene is double, ane is single. And let's do some practice. We got 1, 2, 3, 4, 5, 6, 7, 8. Or you can name it the other way. 1, 2, 3, 4, 5, 6, 7, 8. And the thing about it, notice how right here is a carbon and right there is a carbon. Triple bonds are so rigid they don't bend. So we got a straight line going on here, but it's carbon, 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 carbon. I'm not going to be picky if you're writing a line angle formula and you bend it at a triple bond. Oh well, but technically that's not how you write it. All right, so we got 1, 2, 3. And this is if we're playing like euchre organic chemistry style. Triple bond trumps double bond, so it's more powerful in terms of where we do our numbering. Oh, that's what it says right here. Number the triple bond, like with alkenes. So we're focusing on the triple bond. So it's 1, 2, 3, or it's 1, 2, 3, 4, 5, 5. So we're going with 3. So, and this is 8, which is an octane. Oh, it's probably some gasoline. It's an octane. All right, make sure I get this right. Okay. So the double bond is right here on the. Well, no, actually. So it's 1, 2, 3, 4, 5, 6, 7. So instead of octane, it's octene. But we've got this other thing happening here. So we got 2 endings. We got 7 octene, 3 ine. And what we put at the end is... Oh my gosh, why is it 7? Oh, this is how I make my 3s. Oh.
Second part later.
Oh my gosh, that was terrible. There we go.
And why is the triple bond the octane?
Oh.
Double bond.
No.
I don't understand where
Oh my gosh.
come from.
Wait, the numbers. 1, 2, 3, 4, 5, 6, 7.
So why did
I
we
get
switch?
it now.
Why did we switch the numbers from the way that they were going?
We were racing.
I was doubting myself, but I was partially wrong. So,
Oh, okay.
octene dash something ine. Let's think about this. 1, 2, 3. Okay, 3 goes with the ine.
Yep.
What's the number? 4, 5, 6, 7. Oh, was I right? Oh, okay. Be confident in yourself. Okay. That's moral story. Okay. So could you write it the other way? Probably. You could probably look it in Google Images and it would pop up as correct. So if you wrote it as like 1 octene dash 2, 3, 4, 5. What's that? Because I was showing counting to the left, and then what about counting to the right? What would get you to lower numbers?
They were trying to throw you off, maybe.
Yeah, possibly.
So is that like the most important rule, like the triple bonds? You want to be the smallest numbers.
Typically, yeah.
Okay.
So.
And then also, is it in alphabetical order? Is that why we do the octane?
No, in that you go single bond, double bond, triple bond.
Okay.
And then after that, you do functional group or this functional group or that.
Okay.
So. All right, doing B. Okay, this one's a little bit simpler. We just got one functional group, so to say. So we'd consider the triple bond and the double bond functional groups. Those are like the minor functional groups. So there's a functional group. So that's what our ending is going to be. Our ending is going to be ine. And our main chain is 1, 2, 3, 4, 5, 6, 7. Same thing if you count here. Oh, yeah. So this is our main chain right here. Let's count that. It's 1, 2, 3, 4, or 1, 2, 3. What's smaller? 3. So it's going to be 3-ine. Oh, it's what type? Heptane? Heptane. So instead of heptane, it's going to be heptyne. And we could say it's 3-heptyne. Or if you wanted to say hept3-ine, that's acceptable also. Why don't I show that?
We pay attention to the thing that's like branching off.
Yes. So that's an alkyl group. Alkyl groups are always named first, so I'm starting kind of backwards. And it's on the, we said 1, 2, 3, 4, 5. So it's on the 5th. So it's 5. What type of alkyl group is this? Ethyl. So it's, I forgot which one it was. 1, 2, 3, 4, 5. 5 ethyl, 3 heptyne. So that's something that would pop up on the quiz or an IB, something like that. Yeah.
Would naming the alphabetic order, would that matter?
If you had more than one alkyl group, then yes, alphabetical order.
But right, but this doesn't matter for the alphabetic.
It doesn't, because there's only one side chain.
Gotcha.
So.
Good question, Brandon.
That's right. Technically, there's no space there. No space. 5 ethyl, hep3-ine if you're writing it that way. Whichever way you like, that's acceptable. All right, then we got this one. 1, 2, 3, 4, 5, 6. This is hexine. Hexine. And it looks like it's on the first one, so you could write 1 hexine or just hexine because you just assume that it's on the first if it's not numbered. Hexine. Oh, and it looks like we got a cyclo something. Propane. Cyclopropane. But it is an alkyl group, so it's not cyclopropane, it's cyclopropyl. If there was a double bond in there, it would be cyclopropenyl. But there's no. So this is cyclopropyl. Because it's a side chain. All side chains have a YL ending. It'll group like methyl, ethyl, propyl, cyclopropyl. This just happens to be a cycloalkane, so we gotta write the word cyclo in front of it. Yeah.
So why don't you, when you're figuring out what the longest chain is, why don't you go down and count the, like the cycle?
That's a good question. Why don't you count that? Because that would make it much more confusing. And they haven't, because in 1919, a group of chemists got together. Yeah. Because it's, yeah.
And so you want the triple bond to be the smallest number, right?
Yeah. Mm. All right. Oh, look at this. Alcohol naming we're saving for another time, so we only got a little bit left, and then the rest is going to be practice time. All right. Example D. What is the name of the following condensed structural formula? For me to visualize it, I have to write in line angle formula.
Me too.
So, I mean, yeah, I would write in line angle formula. So we got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We got a CH3, that's a primary. We got a CH2, that's a secondary, all right. Ooh, we got a CH.
Two of them.
2 of them. So this would be CH. That would be, oh. I think that's it. Is that, yeah, that looks about it. So that's not an alkyne. What's that doing here? Is this in the alkyne section? Okay. Do we get that right? Yeah. Okay. So what I just did was 1, 2, 3, 4, 5, 6. So I got 1, 2, 3, 4, 5, 6. And then, I mean, at this point, if you need to write out all of the H's, then you could do that. But I got CH3, so there should be 3 H's. And then a CH2, that's always usually a secondary carbon. So we got H and H. And then CH. That means there has to be an alkyl group hanging off. But it doesn't say that there is one. There's nothing in parentheses. So that means there's probably a double bond. H, H.
So then would it only be 5 in 5C chain?
1, 2, 3, 4, 5, 6. It just means that there's less hydrogens than a normal alkane. So this would be an unsaturated hydrocarbon. Although it's kind of weird that it's in the alkyne group, because it's technically not an alkyne. This is an alkene. So we would call this 1, 2, 3, 4, 5, 6.
So 1, 2, 3.
Hexene.
Oh my God!
But then we got to put a number somewhere. A 3. So this would be 3 hexene. Or you could write it as hex3ene. Alright, so that one's not too bad. That's kind of something that would pop up on the quiz or in the IB. What is the name of the following condensed structural formula? Alright, this is, looks like it's more in the right place here. We got 1, 2, 3, 4, 5. Since there's no alkyl group hanging off, and there's a carbon without any H's, it would suggest triple bond. 1, 2, 3, 4, 5. 1, 2. I'm going to draw it incorrectly. 1, 2, 3, 4, 5. I got 3 H's, no H's, so there's probably a triple bond. No H's, 2 H's, 3 H's. All right, I would rewrite this technically because triple bonds can't bend. So we got 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5. That would be a more accurate representation of this molecule. Before we name this, well, don't look at the joke. All right, so we got 1, 2, 3 or 1, 2, which is 2. And this is 1, 2, 3, 4, 5, which is triple bond. Pentine, 2-ine, or 2-pentine.
Oh my God.
So it's either 2-pentine or pent-2-ine. And here's the question of the day. Why is organic chemistry so difficult?
Because it's those who take it have.
Yeah, you butchered.
Because those who take it have all kinds of trouble. Okay. Yeah.
Why can you name it with the number in the middle? Like, why are there options 6?
Because in 1919, a group of chemists decided.
But like, there.
It does. Go with this. I prefer this. This is the more common one. But if you type it in Google, you can see this. It is unnatural, yeah. It becomes more natural when there's a lot of triple bonds and alcohols and carboxylic acids all in the same molecule. Then this is kind of the only way. But for these simple ones, it makes more sense to do that. So this only makes sense when it's a super complex one that we're not going to do in this class. Exactly. All right. One last thing, guys. Aromatics. Aromatics is just a fancy word for, well, it's the umbrella word for different types of molecules that have a benzene ring in them. Remember, a benzene ring is a hexane with 3 double bonds. And an aromatic is any combination of that. Anytime you got like an alkyl group off the benzene ring, it's an aromatic molecule. All right, so there are 3 conformations. So this is kind of like more organic slang like iso and isopropyl alcohol. You got the ortho, you got the meta, you got the para. This is talking about the functional or alkyl groups that are hanging off. How are they related? If they're right next to each other, it's the ortho conformation. if they are separated by a carbon without a alkyl group, it's meta. And if both alkyl groups are opposite of each other, it's called para.
Do we use that to name them?
Not the IUPAC naming, but you might see it in like slang, like ortho dimethylbenzene. But if it's if you got dimethylbenzene, you know that it would be ortho conformation. But you might have a question that says the molecule is produced in the para conformation.
And then benzene is the one with 6 carbons and it's got a circle in the middle.
Yep.
That's just what benzene is. That's just
Exactly. This is benzene.
okay.
And aromatic molecules are basically benzene ring that has alkyl groups attached to it. Any molecule that has that is under the category of aromatic.
So the little circle is always referring to like 3 double bonds.
Yep.
or something?
Yep. Or you could write it as that. And technically, there are not single or double bonds. These are in between bonds. Resonance. Yep. All right. That is that. So next, we're just going to do some practice.